Okay, example 4. We want to find the asymptotes, the intercepts of the function, and graph the function. So we have x cubed over x squared minus 9. So the first asymptotes, we're studying the in behavior. We need to find the degree in the numerator, so the largest term degree in the numerator, which would be 3, and the largest degree in the denominator is 2. So since the numerator is larger than the denominator, we have to divide, and we know that our in behavior is going to look like the quotient. So this is just going back to our table, the boxed in table, where n is greater than m. So when we divide x cubed by x squared minus 9, we'll get an x here for a quotient. So the in behavior is q of x equal to x. So we're going to actually have a slant asymptote. So our function will approach this line at a slant as we approach both a negative infinity and infinity. So that would be your horizontal asymptote, in this case slant asymptote. What about vertical asymptote? So we need to solve x squared minus 9 equal to 0. So we can factor this. What values would we put here and here? We'd have a 3 and a 3. One would be plus and one would be minus. So the values of x, where our function x squared minus 9 equals 0, are positive 3 and negative 3. And we just want to make sure that those values don't cause the numerator to also be 0. And they don't, so we know that we'll have a vertical asymptote both at x equal to 3 and x equal to minus 3. So if we looked at the in behavior and at the vertical asymptote, now let's look at our intercepts. So the x-intercept will be where our function f of x equals 0. So that's where the numerator will also equal 0. So if we have x cubed, the only 0 in this case would be x equal to 0. And if we plug in 0 in to the denominator, we would just get a negative 9. So 0 over negative 9 is indeed equal to 0. So we have an x-intercept at x equal to 0. Now let's look at the y-intercept. The y-intercept will be where we plug in 0 for x. So we'll get 0 cubed over 0 squared minus 9 and equals 0. And obviously you can tell that from the x-intercept that we got 0 as the x-intercept, so we know our y-intercept will also be at 0. Okay, so now we want to graph our function. So the first thing we can do is draw our vertical asymptotes and the slant asymptote. So remember, we found a slant asymptote of qx equal to x. So that's just going to be a line. Hopefully I can draw this. I'm doing it dashed to indicate that it's not actually part of my graph. Okay, and then we also have vertical asymptotes at x equal to 3 and x equal to minus 3. And so we have different defined areas here, 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 and here. So we know our graph's going to be somewhere inside those defined areas. Well, we know one value of our graph. It passes through the origin. So we could put a dot there. And then to figure out, we know it's going to approach our asymptotes, but we want to figure out where it actually approaches them. Well, we can just plug in values. So we could see if we plug in a -2, what would we get out? Well, we would get out a positive value. So we know our graph must be approaching our vertical asymptote x equal to -3. From the right, it must be approaching positive infinity. And then since it passes through our slant asymptote, and remember our graph can actually pass through slant asymptotes or horizontal asymptotes, but it will never actually cross a vertical asymptote. It then must be approaching, x equal to 3. From the left we approach towards a negative infinity. Because if we plugged in values closer and closer to 3, we would get negative values out larger. So now let's see what's happening to the left of x equal to -3. Well, if we plugged in a -4, we can calculate that. -4 cubed times a -4 squared minus 9. So we would get -64 on top. And 16 minus 9 get positive 7. So that's a pretty large negative number. So it's going to be below our slant asymptote. So we know it's going to look something like this. Then if we're going to do the same thing, plug in positive 4 or 5, see where we're at. We'll see we're actually above the slant asymptote. So it's going to be something like that. So something roughly like that is a sufficient enough graph.